Yo everyone, welcome back. This video is about metatables, where we will go through and talk about what we can do with metatables and see what kind of things we can come up with. And in this one, I'm going to do some things I've already prepped. So let's make a new script. I'm just going to call this metatables. And what are metatables used for? So let's just go on the document and let's just have a look at what metatables are used for. Metatables, let's just go look at that. So metatables allow tables to become more powerful than they are before. They are attached to data and contain values called metamethods. Metamethods are fired when a certain action is used with that datum that is attached to it. So there's our table there, or example table. So this code will search through the list for the third index in the list, realize it's not there and return null. That's totally wrong. What really happens is the code will search through the list for the third index, realize it's not there, and then try to see if the metatable attached to the table, and see if there is a metatable attached to the table, returning null if there isn't one. So it does two things actually. So it's checking here in the data we can see for the third index, which in this case there isn't. But at the same time, after it's done that, it will check for the metatable, and if there is a metatable, it will ask the metatable to call the __ index method, which we'll see below, and it will use that value if that's existent or if it's returned. So we'll see what we're talking about in a minute, but let's have a look at manipulating metatables. So two primary functions for giving and finding a table's metatable are set metatable and get metatable. So we can get them and then we can set them. So the set metatable also returns a table that you're setting the metatable of. So these two scripts do the same. Okay, so we've got local x equals a table, set metatable x to the value. Local x equals set metatable, a table with a metatable. So what x is becoming in the second example here is the first table for set metatable. And here we have the meta methods that we can change. So meta methods are the functions that are stored inside a metatable. They can go from calling a table to adding a table to even dividing tables as well. Here's a list of meta methods that can be used. So we've got index, new index, call, concat, unum, which is unary. Is that negative? No, I don't know what that one is. But as you can see, we've got a lot here. So we won't look at all of them. Some of these we can't even use, like the _ G. So yeah. What we'll be doing is creating a special array. I'm going to call them number arrays. And we are going to utilize these four meta methods here. Actually, we'll do all of these ones here. We'll do all of these. And we're going to utilize these meta methods to make it so we can give resultant tables. So let's create an object first. So an object is a table of data that has methods attached to it, and we can create a new object with those meta methods attached to it, or those methods attached to it. So what do I mean by this? So let's say local class. We're going to go straight off the bat. I'm going to make some code. So with our class, which is where our data is going to be, or our class is going to be created from. So we have function class.new. So this is going to say, okay, we want to create a new class. And then if this was a module script, we would return class here, but it's not, so we won't. And in this case, what we want to name our class is a number array. So what are we going to allow with this number array here? So let's create some meta methods. So what we need to do first is say, okay, when we try index this number array, if it's not found in the data, we want it to check the metatable. So to make it check the metatable, also, we want to add this __ index here. So this will check. So let's say if I put class name equals number array, if it's not found in the data here, it will look in here, and then it will find class name there. So that's what _ index is for. I was meant to say that to look in the meta method table, we've got to use get meta table. So what we're going to do instead is let's create our object initializer here. So this is where we have our object. So what example do they give here? So it's just local x. Okay, we'll just follow this in. So local x equals set meta table, this table with this meta table. So in our case, our meta table should be this one, and our table should be an empty table. So we'll leave it like that. And we don't really need to do anything else with x, so we're just going to return it. So now we have returned a table that is hooked up with the meta table being the number array here. So what we want to do is, let's just say we add something to the table. We don't want it to do anything because we only want specific methods to do things. So if I do function number array, let's say average. What I want this to do is I want it to add up all the numbers and give me an average value for all of them. So how do we do this? Let's do, so actually this is attached in the meta table, not this table here, the data table. That's an important note to take because we are using colon, we're not using dot. So what we want to do is we need to refer to self. So my object self, I want to do for, we don't need the index, but we do need the number in ipairs, since this is a table and it's going to be an array. So for every number in myself, do, let's get the local total. Let's do total plus equals number. And to get the average, we do total divided by the number of self. So the number of items. Like so. And then we want to do another one. Let's do max. Let's do local highest equals self 1 or 0. So this is saying get the first number that's inside my number array. Otherwise, if there is no number, just make it 0. And we want to return that number below here. But we also want to check if there are any numbers higher than that one and set it to that. So we'll do the same thing. For underscore number in ipairs self. If number is larger than our currently highest, then number equals highest. So we're going to get the max number that we can find. And then we also want, or the highest number we can find. We also want min, which we'll do the other way around. We'll say if the number is smaller than the lowest, set it to the lower. Like that. So now that we've got average, max, min, now let's do, let's make the ability to add two tables together. So that would give us the sum. So let's do function number array sum local total equals 0 for every number, add it, and return the total. So in our case, we can actually do self sum and just divide it by the number of self. So we can change average to make it do that, and that's optimizing there. And then what we can say is function. So there's two ways you can do this. You can do this here. What is it? Add equals function self other. I think that's what the parameters are, but that kind of looks ugly. I want to do it a neater way, which would be function number array colon underscore underscore add. And then that would be other. So we don't actually have the self anymore because we've already got self-defined under the environment, pretty much. And then all we have to do is return self sum plus other sum. And obviously this other may not be a number array. So we need to do a assert. Assert other dot class name is equal to number array, which is this here. So we're checking if they have the same class name. And then if it's not, passed value is not a number array. So now we're saying, okay, if the class name is not a number array, then we need to error with this message. Passed value is not a number array. And then we can also do here, we can do sub or subtract. So we'll just make that negative now. So we've got add, sub. We've got mult and divide. So we've got mult. And we've got divide. So this case it would be so we'd call it by number a divide by other. So 5 divided by 4. So we should get back this one divided by that one. So it's self sum divided by the other sum. So that's correct. So now we've added our meta methods. We also want modulus and power, so let's add that. So let's do mod. And let's do power. So you can see it's pretty simple adding it. In this case, I'll use math.power. I don't know if it's faster or not. I haven't really checked, but math.power. And you can do like all of this. You can do like toString. So function numbers array, toString. In this case, we don't actually have table. We only have self. So we do return table.concat self. And I'll just put a dash between them. So that's just saying for every number, join them together with a dash in between. So it'd be like 5-4-3-2, something like that. And then this is an equal one. So function, I'm actually better add this one. So function equal value. So that would be other. And we want to do return self sum is equal to other sum. So that's something you might want to change. You might do it for every number. If it's not in the other one, or if it's not in the same spot, then it's not equal. But for this one, I'll just do sum. So that's less than operator. You got more than operator. You know, you can do all of this for it. So that's only for like this number array thing. So this won't be for like every use case. And as a matter of fact, I can actually just pass in. So this triple dot means for all arguments that are being passed after this point. So like if I have A, then that. That's not going to have A inside it. It's just going to have everything else that's after A. So by doing that, we can say, okay, for every number, just add it straight into the table. So local num array. And then we can call our methods. So we've got new, we've got average, we've got sum, min, max. And actually, since it's here, we can actually see what ones we've got now. So if I do to the power of 2. So actually, we should print numRay sum. And then we'll do power of 2 because it's going to do the sum first and then do the power of 2 for that. So if we have a look at that. Index number with class name. Oh, sorry. Yeah, that's the that would be power is the number. So if type of number does not equal to number, pass value is not a number. My bad there. That should be that. I didn't think that one through. Other, so that should be number divided by number. I thought something was off, but I didn't realize it was that. Sub. Oh, I see what I was doing now. I was going to make them so it subtracts to 2 different arrays. So yeah. My bad again. Let's go back. So we can actually do 2 checks here. So if I wanted to do if type of other is equal to number, then number version, else power plus sums. Something like that. We can do something in that case. And then we're going to have this one here. And that one up here, which would be other. Like that. Else, we can just error past value is not a number or number array. Actually, we don't even need that else there. We can just error it at the bottom. But yeah, so we can do something like this in the case. And if we just try power it, so that's what the power is, it will do that. We can see we get 28, and then 28 to the power of 2 is 784. However, or actually I should say it's the sum. So sum it all up. And then the second one is the sum to the power of 2. But what if I want to do 2 number arrays? Where we do like 1, 2. So that'd be to the power of 3. And then I say number array to the power of number array 2. So that should be to the power of 3. So if we do 28 to the power of 3, 21952. Yep, that's correct. Because 1 plus 2 is 3. So it's the sum of that to the power of the sum of that, which is 3. So our methods are working correctly. So that's what meta methods sort of are. You can, it's like additional ability with the function. Like you can do extra shit with it. It's pretty handy. You'd see this sort of NumPy arrays from Python. I'm pretty sure they use something like along these lines where you've got like the equal operator, you got like two-string operator, you got power operator. Because in NumPy you can actually multiply arrays together. You can add them together. You can sum them. You can. That's sort of where I got this idea from. You can average them. I kind of straight up took this from NumPy array, but yeah. So you can do this sort of thing with metatables, and it's quite handy in some cases. And having objects themselves, it can save you a lot of trouble because you can do methods as well as... Actually, if I do this here, num array max, we can get something like the max value, or the highest value. Num array min. You know, screwed the function there. Min max. If number is larger than highest. It is IP, isn't it? Print number, highest. If number is larger than highest. Oh, highest equals number. Yep, that's fine. There we go. Lowest equals number. There we go. So our highest number is 7, our lowest is 1. So we can see that's working correctly. Just make sure you implement your algorithms right, otherwise it'll mess up. But yeah, hopefully you've learned something from this. They're pretty simple. It's more that when you're doing object-oriented programming, it can get messy really quickly. So that's the tricky part, but metatables themselves aren't too crazy. It's just when you first look at this, you're like, holy shit, there's a lot of them. But yeah, so cool. That's pretty much if I try to do like num array 5, it will trigger the call function because I'm trying to call it as if it's a function. Underscore new index. So that's pretty much if I do like num array dot epic equals true. Since it's not existent already, it's going to call that underscore new index, because it's when finds when table index tries to be set to a value if table index is nil. So only if it's nil, it will set it, or it will call that. It can also be set to a table, in which case that table will be indexed. So also another note is, if you have this set up wrong and you try to do a new index, you can actually crash your studio because it's going to keep calling that new index over and over. So there's also some other methods called raw set and raw get. So it gets the real value of table index bypassing any meta methods. So in case you need to do anything like that, raw set and raw get are your friends, and raw equal also. So those ones bypass the meta methods, but it's still like using index, still using new index, still using equal. So, or it's like you're adding values, you're looking for values, you check if values are equal. So that's sort of what that is for. But yeah, hopefully you can look through these. you can see there's a few there, concat, like there's a lot here you can do, so just keep that in mind when you're going through it. They got more examples here. And yeah, hopefully you've learned something. Have a look at these if you want, and I'll see you in the next video, which is more about filtering enabled, which is going to be the start of the Roblox core stuff. So see you then.